Hello, we are Team 6. We will explain our progress and result of this project. This is our final presentation procedure. In recent years, deep reinforcement learning has enabled impressive capabilities in robotics, such as learning complicated manipulation and learning to adaptation in unstructured environments. We introduced before a learning framework, Maple, that augments the robot atomic motor action with a library of versatile behavior primitive. A method learns to compose these primitives such as reach, grip, push, and atomic, which is non-defined primitive. This enabled the agent to solve complex long horizontal manipulation tasks. They found out that Maple significantly outperformed from this baseline. However, it was still confirmed that learning was not well performed on the tasks that require complex and sophisticated, such as tag insertion. We will explain how we have approached this problem for this semester and how we try to solve it. For solve this problem, recent work has harnessed pre-built primitive. However, these works are limited as they are confined to using only one or two surface primitive. Maple method adopts a set of versatile primitive to solve diverse manipulation tasks. And PAMDP is the method that the agent executes the parameterization primitive at each decision-making steps. Affordance is effective method to equip the agent with affordance that help to discuss the utility of action in different settings. It encourages the agent to specify the reaching parameters X to be within a threshold of the set of the key point P. However, in the actual replication, it was observed that the depth of the end effector was shallow. That is, it did not reach the target portion well. We proceed with replication to improve the problem of these two parts.
From now, I will explain replication and implementation process. There are 8 running environments in the Maple. Among these environments, we chose one environment that we will do experiment, because the training time needs at least a day. Thus, we have to find an environment that is fast to training and converge and has proper difficulty to model to run. So we chose a stack environment as our experiment environment. Here are some examples of training results during replication step. Compared to other environments, stack environment is fast to converge and train, so we chose it. Our implementation plan is two-folded. First, modify primitive to Maple, especially add, remove, and adjust. Second, improve primitive selection strategy via affordance score. The detailed explanation will be in the next chapter. In Maple, there are 5 primitives that the robot can act. Basically, each primitive except atomic primitive, they are all consist with sequential atomic actions. For instance, reach primitive can be consist with up to 15 atomic actions. In Maple implementation, grasp primitive consists with reach primitive and gripper close primitive at the end of it. Especially when the end effector reaches to target position, grasp primitive induces calling close primitive. However, we think as the number of primitive is small, the system is more robust to any scene and any environment. In conclusion, we removed grasp primitive in unusable primitive set and add close primitive which closes their gripper of robot. However, there are some problems to implementation. To give a Maple code which is not implemented as grasping something, so we have to change this part of it. Also, the model cannot learn well about calling close primitive after reach primitive. In other words, model cannot learn the connection between successive primitives. Finally, the function which checks contact is not reliable. Grasp is not reliable. In below 2 figures, both of them are regarded as grasping because those are contacted with object even if right one is not in grasping state. Unfortunately, we cannot find the solution for third one. So I will explain the solution for first and second problems. To first problem, we call gripper release primitive when the reach primitive is called, and change environment setting and reach primitive setting to reach target object position. Second, solve this problem with training more epoch and change environment reward, especially increasing lift reward and grasp reward. Here are 5 lists for results of our experiments.
We have applied the two of the idea about Alperdon's strategy. Alperdon's reverse was given as the full reward if it is only in the boundary. So we assume that the reach position accuracy of each position can be increased by paying reward in proportion to the distance. The second strategy is the score metric. The author calculated the threshold within the check-shape metric. So we assume that it will be more accurate to give rewards as the distance between reach position and end effector, which means the Euclidean metric. So we apply the first solution as the Riccilello. Riccilello, inside the threshold, the closer the distance is, the more fully rewards are received, and further the distance is, the more penalty is received. This will leads to a more sophisticated reach position. However, this exceeds from the 0-1 boundary of the Alperdon score. So we have to lift this restriction. A second one is about the score metric. The experiment was conducted on the stacks by changing the metric in the second approach, which is Euclidean. And this is our result.
Here are our results. As a result, we failed to change the primitive modification. So I will show the progress results of our experiment. At the earlier stage experiment, the gripper cannot reach the target position and the gripper moves with the gripper closing. At the middle of the experiment, the gripper moves with a releasing gripper. However, the end effector cannot reach the stacking target position, especially along the z-axis. At the last stage, we think the reason why reach copy primitive cannot grasp the object as limited number of action calling. So we increase it, but it doesn't work at all. However, what's encouraging is that when we see the first set of video, the end effector moves like origin maple movement. So if we solve this problem, this approach would be worked.
As a result of the experiment, it was confirmed that the performance of the Riccilello was improved compared to baseline, but there is no dramatic change was observed. Although it may change with increasing epoch, optimization was completed with 1000 epoch in most experiments. Therefore, it is just that it is difficult to expect a big change. It can be seen that Sigmoid also produced a similar result. This is remarkable that the performance increased effectively with only a change in the metric. This shows that only the distance between the reach position and end effector initially established is only main factor. And this is the comparison between the D2 metrics.
And here are our discussion. To primitive modification, we failed to modify the primitive set for Maple system. However, we can suggest the future direction for hierarchical modeling for end effector attached robot system. To primitive selection improvement, our method improved the efficiency and performances in terms of reward and task return values. Here are some limitations. First, Maple needs a lot of time to converge to show some concrete results. So we couldn't run many numbers of experiments. Also, we conducted experiments only in stack environment. However, except push primitive, the stack environment consists with other primitive, so it will show similar results in other environments which do not use push primitive, such as door and pick and place. We suggest some future work directions for with our project. First, current mapper affordance score considers only the minimum distance. So adding a connection between successive primitives may improve the mapper. Also, if there are some data set about sequences of primitive tests, we may build the decision tree data with the data-driven method, which can help the connection between two primitives. In conclusion, we try to improve the mapper, which trains the robot and each action with a primitive set. In current setting, the mapper model cannot learn the connection between previous and next primitive, which will be selected. To improve selection of the next primitive based on affordance score, we did experiments with several activity functions and show our method are more efficient. Thank you for your watching.